Hey, that makes me happy. I ordered everything. I ordered, and you know, like the table one, and I ordered, two. Lido Tower.
Sophomore year.
There's no 4.2.
I was like, wait, I knew like the 5. Yeah. Well, like, I don't think for this one, but I'm like, that's gonna go up because of the number 2.
And then it should be another 4.2.
I did those first ones, and then I also have, yeah. Oh, yeah. Okay. I didn't go to my, I didn't go to my 4.2, you know, okay. Yeah, okay, so that's 1, 2, 3.
Oh, yeah, because we're a small class of campus. I did my extra. Wait. All right, so there's 2.
I just gotta look up.
They're both dead.
Oh, yeah.
If you ask, should I go to practice? No matter what practice it is, I'm gonna say no.
So you're taking your.
I don't know, my dad is being weird about it.
No, I can just go with Cameron, but I would have gone with Chen's parents.
I'm gonna talk to my dad.
I would have gone with Chen's parents.
Okay. No, my dad was like, what?
Can I talk to you?
Yeah, I wore mine today.
I was like, I don't know yet.
I took it off. I forgot to take it off.
Have something at the same time.
Yeah, I would eat that one.
Do you buy one today though? No, you got it free. I got mine.
They don't want me driving up there alone, and then I'm like, okay, then I can drive other people, and they're like, no. So what do you want me to do?
Basically. You actually gave me half my take back. You actually.
My pain.
What? Yes, I noticed he's there. I helped Byron. Also, Grace, I have a triple A card. What's great? It's like, I don't understand. Grace, tell Byron I have a triple A card. Tell Byron I have a triple A. Oh, why is he tweeting? Oh, why is he tweeting? Probably doesn't tweet anybody. No, it's not. It is. He's the number one computer.
Don't reason to scream at the person right next to you. I'm in LA. No, tonight. Yeah.
Wait, I don't know. Jump off the block and touch my hair. I
I know you don't be wrong.
Dark blue. What? Purple.
Yellow, blue.
You guys live in 12 man. I think we're done. I didn't know I'll give you for up. Straight up. I need to get loose. Bengals wide receiver. My old. Man, always your team I've been cited this way for like the last
Not like
I thought I'd been clear about the volume level and the decibels. There's no reason for this. You could calmly let me stand. Please, that'd be great. Yeah. And then video takes like 8 minutes and then question. Oh, no, I see. I
Josh, minus 67.
Okay, guys, thank you very much. Okay, so hold on the notebook real quick. Find your blue sheets. We're gonna finish that first. This is the last little bit of it. It's exciting. What's wrong? She was just like slouchy. Okay, anyway, all right. Guys. Using studies wisely, last little bit of the chapter, the fact that different random samples of the same size from the same population produce different statistics. Larger samples are more precise. This is called sampling variability. It means that if I randomly select 5 of you and measure you, and then I put you back in the population and I randomly select a different 5 of you and measure you, you're going to have a different average height than the other ones. Just means that things vary from sample to sample. That's just a fact. When the observed results of a study are too unusual to be explained by chance, this is called statistically significant. Our results on our hand reaction test were not statistically significant. They should have been, but there were some snafus that happened. Yes, yes. So you're looking for p-value less than 0.05. And you can say less than or equal to, you can say less than. It's very rare to get one that's exactly 0.05. I don't think that there's one in the whole year that comes out to be actually exactly 0.05. I don't think that ever comes up, but anyway, okay. Random sampling allows. Okay, so this is very different. Random sampling versus random assignment, these things sound very similar, but random sampling is a survey. So you're randomly sampling people to ask questions or measure. So that was the cluster sample, the multi-stage sample, the systematic sample, all of those. If you have random sampling, it allows you to conclude I'm going to say actually to generalize. Okay, so if you do a survey, let's say you ask 100 students from Venetia High what their favorite food is, or whatever, and you're talking about that. In your report, you could say, well, 76% of my survey liked pizza the most, so I could generalize it about 76% of the whole population likes pizza the most, but you can't say why. You just say what you observed. And you could say what you observed in your sample is probably the same as what you would observe from everybody, but you can't say why. There's no why established there. It's just, this is what I saw from these people, so I'm probably gonna see the same thing from everybody. But no why. Okay, now for experiments, it's the opposite. You can say why. So random assignments, that's what happens when you have an experiment. And when you have an experiment, you can tell whether or not the treatments actually cause some kind of change or not. But you can only say that for the type of things that your experiment was on. You can't say that about everybody. You just have to restrict that cause and effect to whoever the experiment was on, or things like the experiment was on. So let's just say I have hamsters and I give half of a group of hamsters a new food and another half of hamsters like some kind of original food, expecting that the hamster coats would get glossier and more beautiful hamster coats. You could say that the new food caused the hamster coats to get better, but you couldn't say that that would work for all hamsters everywhere, just hamsters like the one that you used in the experiment. Okay, so random sampling means you can say that about everybody, but you're not sure why. Random assignment allows you to say why, but not for everybody. Awesome, things are backwards. Okay, so let's extend that into what we did yesterday. To go back to this is done. Yay, blue page is done. Okay, now move back to your notebook. Okay, we obtained a p-value of 0.409 for from our matched pairs experiment. Sorry, that's the spray that I use at home to clean my kitchen counters. So I see 409 and I can't help it. This means that our results are they statistically significant or not? No, sadly. Hmm? Less. Okay. I can hear you talking. We had some snafus in ours though. Dominant hands should probably be faster. But we had some outliers. So you guys want to talk about this any further? Like what the p-value is? You can't really calculate it yet. You don't have enough information to do that in your stats toolkit, but you will be learning that. It's just that the computer did it for us with the hand reaction experiment. We're just like getting into this. It's not, we're not there yet. Yeah. What? Okay, all right, what can we conclude from our hand reaction time experiment based on its design? Okay, so this is very specifically talking about its design, not from this. We can't really conclude anything, to be honest with you. Ours was so messed up, but from its design, which one of these things did we have in the hand reaction time experiment? Did we have random sampling or random assignment? Assign. Did I select random students to do it? No. Yeah, I forced you all to, which is completely immoral for an experiment, but it was fun. And I randomly, well, the computer randomly assigned you either the order of your treatments or which one. Does that make sense? Do you guys see the difference? Okay, so since there was random assignment, we could have concluded since there was random assignment in this, we can't conclude anything because, you know, things happen. But we could have concluded that using the dominant hand caused faster reaction times, but only for people like our class. So for only people in your age group, in an AP class, in Benicia, people just like you. It would not necessarily be true of like, say, 80-year-olds in like a retirement home. They probably would not have had the same sort of results. for obvious reasons. Okay, now I switched it up. This is not the same thing as this. This is just completely separate because I had to think of something to say for the other one. What can we conclude? Oh, do you need a second to write this? Okay, sorry, my fault. Really gonna make sure to bring that calculator to the test for this class. I'm joking, we hardly used it the whole chapter. What can we conclude about a survey of randomly selected AP Stat students' satisfaction rating of this class? This does not have anything to do with the hand reaction time thing. I just had to come up with something where it was randomly selected instead of randomly assigned. Okay, so what we can conclude, since there was random sampling, we can conclude that the results apply to all AP Stats students but cannot conclude cause and effect. So I'm going to break this down to teenager. Everyone since there was random sampling, we can conclude that the results apply to all AP Stats students, but cannot conclude cause and effect. That basically means everyone feels a certain way about the class, the whole population, but we really can't conclude why it's happening or what it's causing or what's causing it. So that's the difference between a survey and an experiment. And if you don't have randomness in your survey or your experiment, you can't conclude anything. You just did a bunch of work for nothing. As a matter of fact, one of my students last year, bless his heart, did an AP research project and did a survey and just took out a complete and total voluntary response survey. Like asked them rating 0 out of 10, calculated averages, did a confidence interval and hypothesis test. You guys haven't learned yet. And at the end, I was just like, yeah, that's cool, but there was no randomness built into any of it, so you can't actually use any of these results. That was all just like for nothing. Now, the really funny part about the project was that it was about procrastination.
Oh, perfect.
So there's all voluntary.
I'm doing something similar in my research, so I have to make it random.
If you want to use it,
I'm like selectively random, like I should recruit people and then some random people.
no. I don't remember whose it was. I just remember we had to write a whole paragraph about bias at the end to sort of cover ourselves. I mean, it still worked. It was fine for the assignment, but I'm like, no randomness built in, no research project. Okay, what I would do is, this is what I would do if I was going to try to randomly select people at the high school. I would go ask Coach T, okay, so take like, do a, yeah, random number generation of like, so there's about 1,400 kids here. And give him like how many you would want, and then have him pick them through Aries because he has everyone's like alphabetically numbered in there. What? He can't give that to you, but he could help you with it. Yeah. And then you'd have to like stalk those people and get them to fill out your survey though. Good luck with that. Okay. Anyway. Okay. Now what we're going to do is I'm going to show you all of the stuff that you've missed in my slides. You've missed several jokes and several objectives. I know, I'm awful. Okay, where did we leave off? Okay, we'll see. Have you seen this joke? We received 500 responses and found that people love responding to surveys. Oh, hey, that's what I was just talking about, my research project. Oh, here's my paranoia survey question. Yeah, I like that one. I like that one. Okay. 10 out of 10 people agree that polling only 10 people isn't very good statistical analysis. Yeah, it's good. It's good. Okay. This is just a hilarious headline that I find is so stupid. This is actually a newspaper headline. Yeah, of course it is. It's an earthquake. I have another one too that says most teen pregnancy rates go down after age 25. It's like a real newspaper headline. Yeah. Oh, here's Newton laying under the tree, and it says reviewers have asked him to reproduce the experiment. He's trying to get the apple to fall on his head again. Do you guys know what vocab word this goes with? Replication, yeah. Replication. That's not funny. Okay, and then this is today's. It says, can my boyfriend come along? I'm not your boyfriend. You totally are. I'm casually dating a number of people. But you spend twice as much time with me as anyone else. I'm a clear outlier. Then there's a box plot. You're madly irrefutable. Face it, I'm your statistically significant other. Very cute. Okay, now back here. So we're actually done with the chapter. What I'm going to do is 2 more things for the period. The first one is I'm going to play you a video. This video reviews the different types of sampling. So if you guys can open your blue sheets up to 4.1b. Open your blue sheets up to 4.1b. There's a lady, she's Australian. Enjoy her accent as we review the types of sampling. Okay. Then we're going to play a card game after that, which is a vocab game. Toby and Jake, I was hoping you guys could, and you guys are gonna have to sit. You're gonna have to move tables. So there's 4. Yeah.
I'm gonna bring.
It doesn't matter.
Right now?
No, just sit, just chill. Goodness sake. Anyway, so I'll explain the card game once we get there. Hopefully it works out. Why am I saying it like that? It's some kind of impending doom. Well, last year there was a definition that people couldn't figure out, and I think I fixed it 3 weeks ago. We'll see. Also, this Vivi speaker system is driving me nuts.
Simple, convenience, systematic, cluster, and stratified. To find things out about a population of interest, it is common practice to take a sample. A sample is a selection of objects or observations taken from the population of interest. For example, a population might be all apples in an orchard at a given time. We wish to know how big the apples are. We can't measure all of them, so we take a sample of some of them and measure them. The method chosen for taking the sample depends on the nature of the population and the resources available in terms of time and money. The ideal is for each object in the population to be equally likely to be chosen as part of the sample. This is called an unbiased sample. It is also desirable for the sample to be representative of the population. If the population of apples were 2/3 red and 1/3 green, the sample should be similarly split. Note that no matter what we do, there will always be sampling error or variation due to sampling, as we are looking at a part of the population, not the whole population. The video on variation covers these concepts more thoroughly. This video presents 5 methods of sampling: simple random sampling, convenient sampling, systematic sampling, cluster sampling, and stratified sampling. For each method, we will outline the process and the advantages and disadvantages. Simple random sample. Simple random sampling is theoretically the ideal method of sampling. You list each member of the population and use random numbers to decide which objects are in the sample. Each object is equally likely to be selected. This produces an unbiased sample, which we hope is representative. However, it can be difficult and expensive to take a simple random sample when dealing with people. Simple random sampling is more practical when the population is geographically concentrated and when a good sampling frame exists. A sampling frame is a list of all the people or objects in the population of interest. Simple random sampling can be more easily implemented for natural and manufacturing populations. Convenient sample. Convenient sampling is just that, convenient. You ask people nearby or people who walk past at a shopping mall, or you take the next 20 objects off the production line.
Those
You
are
do
shoes,
what
I
is
think.
easy or
Just saying.
convenient.
I think they're shoes.
Convenient samples are often biased in some way, but for a quick and cheap poll, it may not really matter. Convenient samples can also have self-selection bias when people choose to participate because they have an interest in the issue in question.
Oh, no, they're
Systematic
chocolate
sampling.
bars.
With systematic sampling, you choose a starting point at random and then systematically take objects at a certain number apart. For example, if there are 1,000 in the population and you want a sample of 50, you would take every 20th object. Systematic samples are easier to administer than simple random samples and are usually a good approximation of a random sample. However, if there is a pattern in the population, certain types of objects could be chosen more or less often than others. Cluster sampling. In cluster sampling, the population is divided into clusters which are then chosen at random. For example, departments of a business can be clusters or suburbs within a city. Within each cluster, all of the objects are included in the sample. Cluster sampling can be more convenient and practical than simple random sampling. However, if the clusters are different from each other with regard to the elements we are measuring, it can lead to bias or non-representativeness. Stratified sampling. Stratified sampling seems like cluster sampling, but the strata or groups are chosen specifically to represent different characteristics within the population, such as ethnicity, location, age, or occupation. Within each group, a random sample is taken, sometimes in proportion to the size of the group. Stratified sampling can lead to a very good random representative sample. However, it can be complex to administer, and a sampling frame with considerable information about the population is required. There are other sampling methods. The 5 explained here give an idea of the advantages and disadvantages of various methods. You should attempt to use the sampling method that produces the best result for the resources you have available. If your sample has known bias, this should be taken into account in analysis and reporting.
Does that help a little bit? Okay.
Yeah.
So now it's in your video, so you can watch this video, and that video will be in the video if you want to review those beforehand. Again, someone in the class should volunteer to make a Quizlet, I think. If anyone's like a Quizlet master, okay. If you could send that to the group chat and make it. Okay, so if you guys could, make as close as you can to group support. I'm gonna give you some cards.
Actually, I'm gonna go.
Yeah, that, he's.
Oh, but I don't want to have it. I just lost my shoe. I got one.
Okay, so. Hold on, you guys, I'll give this to you in a second. Okay, so get everything off of your table, like just scooch it all down to one side. You're going to need table space. Yeah, and take them out and shuffle them up as best you Okay, and what you're going to do is, you're gonna turn them so you can't see them, you're gonna deal them to each person, oh, wheel around, and everyone has a wheel around. What? Just until they're gone.
What are the marks? Types of animals, their dominant traits, types of plants, how they adapt.
Okay,
And any like
All right.
special thing. like hormones.
so, okay, so, you guys, are there any left over? Yeah, okay, if there's a leftover one, put that card in the middle of the table. Oh, wait, if there's not, so just put one, so if you have more than everyone else, just put one in the, it doesn't even matter, just start with one in the middle of the table. Take that. Okay, so what you're gonna do is, you're gonna read the definition at the bottom. And then you have to look at your cards and see if you have that one. And if you have that one, you're gonna put it next to it. And you're gonna keep going, and if you do it right, it should come back around to the first card for the definition. Do you see what I'm saying? Okay, start with one card on the table. Yeah, it's like a circle. What? No, because then I'll give it away. So just put one down. Okay. No, just one of those. Next card is. Just finding a book out where that goes with
Contract by the- She's a train.
Mine doesn't have it.
So what do we do? You just read out your cards.
Yeah, okay, so then that goes here, and then you go off of it, and then keep going, and your last one should be randomization. Go back.
Quantitative data.
Yeah.
Like you get, if you get.
Is that a statistic? Is that a statistic?
Oh, yeah.
This might be here. This is like this here. That's like a placeholder.
Maybe, oh. Okay, coming around with the key whenever you think you're ready, speed check.
Josh, who's data?
Around the shape, around the shape. That's what I just said. Yeah, it's like my part of the
Yeah, they should. I think.
Yeah, the collection of all outfit responses, measurements.
The number, maybe there's a circle, the number of 6 feet apart equal.
Blinding and left.
Oh, wait, this goes here. This one's answer is placebo. What is groups of subjects with similar characteristics? This one's answer is more
This goes here. It's in the process of rounding. This one, what is blinding? This is here. This makes sense.
why is the process of randomly assigning subdivisions and treatment statistics?
Done by Miller.
This is not.
Oh, no, no. Would that be right? That doesn't make sense. That doesn't make sense. Yeah. Yeah.
Are you ready, BJ? Oh my God.
I said. Yeah, that's statistics.
These are.
I did not even say
First place.
This is blinding.
I don't know.
This is blinding.
Is it not?
Josh actually, yo, Josh is actually. Josh is so geek.
Okay, this is data.
Bro, what did you take over this class? That's really important. We have an umbrella. We made an umbrella. All the circle, right? No. All the circle, right? Wait, this is actually a circle.
Oh, it is? That doesn't happen.
That's how we're not doing it.
If you would say this was
Oh, this is survey. Do you remember that? That's
Except who has the science and collective knowledge? I thought they I think it was Okay, let's go. No. Okay, that's right.
My strategy is to get college out. Not until Thanksgiving break that up. Applying to Stanford and MIT, but
Actually, like.
for when the Bears go on bye.
This has to go somewhere.
guys ready? Check.
We're not. Oh, no, I think that's-
I was like, you guys are looking for like this. Oh, sorry.
Application
Thank you
is
for your help,
just-
Gustavo.
after application is Yes.
Here, what is mathematics? Josh is geeked today. Yo, do you, I remember watching Kill Bill at Josh's house.
Oh, it was data.
Oh, there you go.
It was the one that.
Remember when he was saying that I wanted to? Like, I don't know where he Are we? Great, how did you cheat? Are we? We're not.
Yeah.
So take this one.
I say Josh, I say, don't take that lightly, just take them all over.
By the bathroom, Jimmy bathroom.
You're a geek.
Oh, I forgot, man.
You're not getting talked to anymore. Not a single word. You all by yourself. What's the lesson plan during lunch? Like last third period. That was Miss Thompson. You have to sit with people she likes. Sit with Josh Daniels, you get kind of.
What do you have?
Oh, sir, characteristic. No, that's what
So sad. I don't know. Your attitude is what is sad.
Here's one
Oh,
thing.
it's supposed to be fun. Okay.
Almost there.
Quantitative
You're the one that.
replication
I thought I was there. We also have-
survey.
I didn't like it.
Sample.
Yeah, no, it's just because I need a.
We did, you had it right.
It's probably because people
No, I didn't.
Well, then why were you sad?
No, we had it right.
Yes, you do.
They thought it was wrong outcome.
Everyone was telling us. that
Because it's like whole everything. So the word all.
This is such.
So you can figure out. You should listen to the people who took the longest senior panoramic photo in all time.